Morning. My name is Sam Chung from Bellingham Technical College. Welcome to the 2014 summer workshop. And this video is give you an overview of Module 3, Register Instructions. And you will learn more about these modules when you attend the 3 days workshop. And when we work on this register, first of all, you need to understand a little bit of the hardware architecture, and that's displayed on the screen. That's based on the screen. So let's look at it piece by piece. The first thing we look at, the architecture is most in the green color is the 8-bit. Therefore, most likely we will operate in 8-bit all the time. And on the center part right here is the program counter. The program counter is 13 bits, and we will see how we're going to bridge from 8-bit to 13-bit later from the special functions register. Since the program counter is 13 bits, therefore, this is keep track of the execution of the program. So when we branch off any instructions like call, go to, and we have to push whatever from the leftover programming code will be pushed in the stack. So after we jump up to the subroutine and we come back and we get back from the stack. And looking at stack is 8 level deep. If you keep pushing more than 8 level, then you will be overwritten the stack here, and your program will be crashed because you cannot go back to original program. So on the left hand side, you can see the program memory. The program memory is a 14-bit right here. The 14-bit is actually when we're looking at the 2 to the 14th bit will give you 16K. But actually we are not operating at 16K because the program counter is only count up to 8K. But even though we give you all this bit, then we're going to split this program memory into the 1K addressable, physical addressable location is 1K. So anything be above 1K will be wrapped around. So what does it do on the left-hand side is this is what the CPU do. So the CPU will fetch the instruction from the program into the instruction register. And then instruction register go to the decode. The decode, we're looking at the opcode and operand. And then will generate some timing functions. The timing function will be either the I/O, operating I/O, or in the internal with the watchdog timer. Okay, this portion here. So this is a very typical CPU working here is the fetch, decode, and execute. This is what the CPU does. Now on the center part here, there's another memory called the data memory. The data memory. So the data memory is divided into two groups. And let me looking at this data memory right here in the next chart. And let me give you another diagram here and looking at the data memory. So this is the data memory is using from the stack, and the stack is on the top, the program counter, and this is the program that we're going to use. And this is go to 3 Fox. 3 Fox is, this is 10-bit right here. 10-bit is go up to 1K over here. And on the top part right here is the reset vectors and also the previous interrupt vectors. Whenever the program start, you always start at the 00, but when you go for the branching, you can come back to the address 04 and then continue your program. Now let's look a little bit more detail about this space, And the next diagram I'm going to show you is this one right here. This is called the special function registers. Okay, special function register. And this is on your page number 3. And remember the architecture, we use 8 bits. And what this special function register is, if I use 2 to the 8-bit, I will have 256 instruction set or addressable. But the architecture is going to use only 7 bits and leave the last bit, the 7-bit here, is for 0 and 1. The 0 at the bit 7 destinate at bank 0 down here. And the 1 here is, of course, is the bank 0 and bank 1. So if I look at bank 0, they all start at 0, 0, 0. And then if we go to the bank 1, we start at 8, 0 here. That's why we split into 2. Now, these two addresses are actually is mirroring each other. That means some of them are shared directly. You know, whatever you set it here, it will share. But somehow some of the bank 0 and bank 1, if they are not shared, but the bank 1 is doing some operations for the bank 0 register. Now, for example, I'll give you a quick example what do you mean by sharing or how it works. Now, suppose going to the port. If we want to go to the outside world, we have to talk to the port. So port B is the 06. So if I want to talk to the outside world or going to grab a data or interrupt, then we have to go to port B. So if we go to port B, then how to set the port B as input and output, and we have to go for bank 1 to set up the condition for port B. So if all the bits are 1, it will set as the input of the port B. If I set in the bank B all the bits for the 0, and port B will be the output port. Therefore, remind you, and whenever you want to do the control, and we always go to this the 12 bytes, which is the special function register, and do the operation. We always switch from bank 0 to bank 1, do the setting, and go back to bank 0 to run your program. So how do I know what is the status of how we set it for bank 1 and bank 0? And this register called status is 03. 03 is having all the flag. We have 3 flag. And also to switch from bank 1 to bank 0 is using the status register and set the bits, you know, to either if I set the bits is 1, I go to bank 1. If I set the bits go back to 0, then I go back to bank 0 to run my program. I run my program here. Okay, let me go you another chart and looking at the operations of the operation set here. And if we're looking at the PIC16, the PIC16 doesn't have a lot of opcode, and these are the opcode to controlling your program. And it's divided into 3 different instruction sets. The first one is called the literal and control operations, literal control operations. Suppose I want to write a number 8, okay, directly go to the port. So 8 is the literal. The illiteral will be using the opcode, any of this opcode. When you see a K here, is referring to the literal. So the literal can be is a 8-bit or can be a 11-bit. Depends on how we're going to use the opcode. And if I use the 11-bit, it will be the call or go-to instruction. That means I'm going to branch it off and need to push the program counter into the stack, and it will use this group here as the opcode. The next set of the instruction set is the bits. Remember earlier I talked about when we're looking at the status register at bank 0 and bank 1, and we have to set the bits to either go to bank 0 or bank 1, and this is what the bit is. So the bit is actually using down here, the bits is we can do the set bits or clear the bit, okay, of a certain register, okay, function register. And this is called the bit operations. We manipulate the bits. The last group here we're going to look at is called the byte register, byte oriented register. The byte-oriented register is whatever we have opcode, maybe do an add, a subtract. As a result, we have to put it back into either working register, or sometimes we call the accumulator, or back to a file register, depends on the destinations. And if we want to report the data or the result either back to the file register or the working register, then we will use the byte operation mode here. Now, after we've seen all these things, then we can come back to the original physical block diagram here and look at it, revisit one more time. Now, this is the called the FSF. FSF is the one that I did not mention earlier. This is for the indirect addressing. So in programming, we know we can do direct addressing and indirect addressing. If we do the indirect addressing, then we have to go through the FSF register. And also in here, let me real quick, and looking at the instruction set here, the second one here. Okay. See this 00 hex here? This is called the indirect addressing. This is not mapped directly to memory. You cannot access that. But when we can use the bank 1 and bank 0 to set this up for indirect addressing. Okay. So overall, the architecture is very straightforward and easy to work on. Okay. And you follow the instruction, all these things is a lot easier to see. This is going to the W register. W register is not a special function register. This is like accumulator. Therefore, as a result, you want to put the result back to the working register or put into the special file. You want to put your data or the result into there. So at this time, I'm going to conclude here and enjoy your 3-day workshop, and you will learn more about the individual programming code. Okay, so if you have any questions, please email me or contact Steve or contact anyone. I'll be happy to answer your question. And have a good day. Bye.